I'm super excited to be here. My name is Anam Jangshe, and I'm the product manager of Amazon Aurora. And here with me is my wonderful colleague.
Hello, everyone. My name is Chirag Dave. I'm a senior database specialist solution architect. And I'm super excited, just like Anam, to talk to you about recently launched Serverless V2. So Anam, take it over.
So in this hour, we have lots of content prepared for you. We're going to start off talking about all the amazing functionality that we have with Aurora Serverless V2, and we have sprinkled it with tons of demos that Chirag's going to talk to you about. The other thing that we paid a lot of attention to was about how can you get started with it. We made it a super simple process that you can follow to get started with Amazon Aurora Serverless V2. So let's get started. Just a little bit of context to get everybody on the same page about Aurora. Aurora is a MySQL and Postgres compatible relational database that is built for the crowd. You get performance and availability that you expect from a commercial database at just 1/10 the price. Now, we also have the distinction of the fastest growing service in the history of AWS. So we are very proud that you chose Amazon Aurora to run your workload on. Now, I'm not going to go deep into Aurora. So the key point to note here is that it is the underlying Aurora architecture that actually brought into existence Aurora Serverless V2. So the main point to note is the separation of compute and storage. So the storage is the purpose-built log structure distributed storage that is designed for the cloud. We have 6 copies of data across 3 availability zones. So you get high availability, durability, and performance. Now, since there's separation of storage and compute, if you think about some routine operations like backup and restores, you can run these backups on just the storage layer. You don't have to wake up the compute for these routine operations. And on the compute side of it, you can have up to 15 read replicas. And these read replicas, they operate on the same storage layer. And now there's separation of compute and storage, so that also means that the compute can scale independently. And I'm telling you all of this about Aurora because this is what we built Aurora Serverless on top of. Now, you may ask, why should you care about serverless? So on the chart here, you see 3 different examples of utilization. In most of the scenarios, you never have a very steady workload that you see. You'll always have like these peaks. So in these examples, I showed you some sample examples that we saw across our own fleet. Here you see you have the peak and then you have the average. So what ends up usually happening is that if people don't want to provision for peak and they provision database capacity for anything that's lower than the peak, then at the times when you hit the peak capacity, your workload hits the peak capacity, you're going to experience some degradation. So the other side of that is that you provision your database for peak capacity. Well, that's expensive. An alternate to that is that you continuously monitor your workload, you look at your database capacity, and you scale your database. You do it manually, and there's a downtime involved. You have this process available right now. You can do a failover. But the downside, again, as I said, is there is a downtime involved. So this is pretty challenging for our customers, and this was the main motivation for building Aurora Serverless. So Aurora Serverless is an on-demand and auto-scaling configuration for Amazon Aurora. It scales automatically based on your workload. And you only pay for what you're using, and you only pay per second. So what was announced today is the next version of Amazon Aurora Serverless, which we call Aurora Serverless V2. So with this version, you can scale your database instantly to support your most demanding workload, and you don't have to worry about database capacity management. Now I'm going to walk you through a couple of examples, some scenarios where serverless is super beneficial. So for the first one, I'm looking at you who runs SaaS applications. Most of the cases, you have thousands, hundreds of thousands of users, and each of these users will have their own database. Now, managing all of these hundreds of thousands of database is a cumbersome task. You don't want to do that. So what you end up doing is you bunch them together in a couple of them in a Aurora cluster, and you do that across your fleet. And again, you get good utilization and cost efficiency from it, but there's a trade-off. What ends up happening is you lose that granularity control over your operations. So let's say you want to do a restore operation for your specific customer. You can't do that because that specific customer is bundled together with hundreds of other customers. So you have to look at this balance between cost efficiency and how much granularity control you want to have. And you also have to continuously, keep monitoring and shuffling your workloads around because you don't want all the customers being on like the same Aurora cluster. So this is where serverless can help you. What you can do is have a serverless database for each of your customer, and this database will scale up and down specific to that customer, based on that customer workload. If it's heavy, it'll scale up. If the customer workload is around idle, it'll scale down. So we take all that pain away from you. For the second use case, now think of a large company. They have hundreds and thousands of applications. And each of these applications, it's backed by a single or multiple databases. Again, now, managing all of these databases is a very challenging task. And the requirement for these applications, they change over time. If your company was smaller, let's talk about HR databases. Once the company grows, the application would require more database capacity, so you need to assign it more database capacity. Another example could be, end of life for an application. You have to take away a database capacity from those applications. So you have to constantly keep monitoring all of these databases, managing them, figuring out what to do. Again, this is super challenging, and especially doing this on a super tight budget is a pretty difficult task. So this is where serverless can help you as well. For all of these applications, you can back them by serverless databases, and based on the workload, those databases will scale up or down. The last use case I want to talk about is for scenarios where you basically hit the limit of your database. In those cases, what you end up doing is you spread your database across different clusters, or you shard it. Now, it's a challenging question to figure out, now, how many nodes do you need for sharding? If you have too few and you see some growth, then you have to redistribute data again. There's downtime. If you create too many nodes, then you'll see that some are super active, some are not so active. So what you end up doing is, again, bundling them together so you get some kind of cost savings. But again, you still haven't solved your problem. So with serverless, what you can do is assign these databases to be serverless databases. So if more capacity is needed, we'll scale up. If it's not needed, we'll scale back down. Now, we saw a pattern across all of these workloads that I just talked to you about. And when we built Serverless V2, we wanted to make sure that the requirements that these demanding workloads require, we take care of all of that. So I'm going to talk about some key functionality here. So for all of these workloads, one of the main important things is instance scaling. Whether it's one database or it's 100 database, if you need capacity then. So instance scaling is super crucial. And more importantly, we got to have the ability to scale non-disruptively. If they're long-running queries, lots of transactions, temporary tables, we don't want to pause them, wait to make sure there's like some quiet point and then do scaling. We want to be able to scale non-disruptively. And then since it's serverless, we also want to be able to follow along the workload as closely as possible. If we're not close to it, then at the end of the day, you're again paying for more. You're wasting resources there as well. So fine-grained and predictable capacity adjustment was another one of the requirements. And the third one is that if you look across your critical workload, there's a baseline of features that you need. You need high availability, so we need to have the capability to, let's say, deploy across multiple availability zones. You need to be able to recover from disaster. You need to have read scalability. So for all of these crucial capabilities that are required for critical workloads, we needed to make sure that all of this was available in Serverless V2. So let's get started with the first pillar that we talked about, scaling. How does scaling work in Aurora Serverless V2? We scale by what we call in-place scaling. What does that mean? What we do is we take a running database process, we give it more resources. You need more CPU, you need more memory, we give it those resources. And as a result, we're able to scale instantly. On the other side, what you've also seen people do scaling is by failing over. You need more resources, you fail over to a bigger machine size. You need less, you fail over to a smaller one. We don't do that with Aurora Serverless V2. We scale in place. And what that also helps us is that we can scale non-disruptively. You won't see any impact when scaling is happening, even when you're running hundreds of thousands of transactions. Now, we have had a lot of experience looking at Aurora and RDS databases, and we have managed those fleets for years now. And we have used that experience for serverless v2 as well. So we monitor it closely to see how capacity is doing. We figure out if more capacity is needed. We scale our fleet horizontally, so your workload is not disruptive. Even though we call it serverless databases, at the end of the day, these databases are an actual physical machine. You may run into a scenario where these machines can run out of capacity, these underlying hosts. What do we do in that scenario? What we do is we look for idle instances. We look for instances where there's no activity or minimum activity, and we move those databases away from the host to another host where there is more room. And we do this non-disruptively. So all your background processes that are happening, your buffer pool, your cache that's there, we preserve all of that. You won't see connection drops. So that's around how you are like scaling up, moving around hosts. Now, if you think about scaling down, we don't want to scale down too quickly, because what will end up happening is we may take away some buffer pool space that you will require, and then you have to go back to storage, fetch those pages again, which is a costly operation. So we scale down cautiously. We scale instantly, but scale down very cautiously. We look to see, is there any pressure on the internal structures? If we don't see, then we scale down a little bit more. Then we check to see, are we good, and do more scaling down. Now, let's talk about buffer pool and how does buffer pool resizing happens. So buffer pool is your main cache in your database. And it is also scaled when we change database capacity. So for MySQL, you have InnoDB buffer pool size, and for Postgres, you have shared buffers. So these two caches, we are managing them for you, because when we're changing capacity, we are increasing and decreasing the size of the buffer pool depending on what your workload requires. So by default, for memory allocation, we assign 75% for buffer pools and 25% for heap, for operations such as like sorting. And for buffer pool scale down, we use a combination of least frequently used and least recently used algorithms. Now, I'm going to run through this animation to show you how does buffer pool resizing actually happens. So as pages are read from buffer pool, they become hotter. And then you can also have scenario where you're reading pages from the storage side. At this point, you don't know how these pages will be consumed. As they're read more, they can become hotter. And when they're not read that often, they can become colder pages, which are more likely to be evicted. If we're going to read them again, we want to make sure that we don't make them to be cold pages, because those are the ones that are going to get evicted. So here in this image, the gray ones are the ones that are the cold ones, and they're more likely to be evicted once we figure out that your database does not, the pressure on your internal structures have decreased, and we can reduce the buffer pool size. So we evict the cold pages, and then we shrink memory back. So this is, the size of this buffer pool is going to match with the database capacity. So now the next point I want to touch on is the fine-grained capacity adjustments. So far, I've been talking about database capacity. So for serverless, we measure database capacity in ACUs, Aurora Capacity Units. So one ACU is 2 gigabytes of memory, and then you get the corresponding CPU and networking with it. To get an idea, that's very similar to what you get in provision Aurora instances. And to start off, the smallest database capacity that is available to you is 0.5 ACUs. And the increments, the smallest increment that we can provide is 0.5 ACU as well. So let's walk through an example. Let's say you are at 16 ACU. At this point, if your workload just needs a little bit more resources, we can go up to 16.5. If it needs more, we'll make a bigger jump. We can go to, let's say, 20 ACUs. So the key point here is we want to make sure that the database capacity is following as closely as possible to your actual workload. So we want to make sure you're not over-provisioning or wasting resources. When we talk about scaling, the next thing organically is to think about what are the factors, when does scaling happen, how does scaling happen? One of the key points to note is that the scaling rate, like how quickly your database scales, that is dependent on the size of your database. So if your database size is bigger, we're going to scale faster. If it's smaller, the scaling rate is going to be smaller than the bigger size. So let's say if you're at 16 ACU, we'll go faster to 17 ACU as compared to if you're at 3 ACU and you want to go to 4 ACU. The factors that basically determine if the database is going to scale up or not are CPU, your memory, and your networking. If your workload requires more CPU, let's say, we're going to scale the database up so you get that CPU resources that you need. If it requires more memory, if there's on the internal data structure, there's more pressure and you need more memory, again, we're going to scale up the database so your workload gets more memory resources. And same for network throughput. If you need more network resources, we'll scale the database up so you get the resources that you need. Now, just in terms of thinking about minimum and maximum ACU. So when you're provisioning, you specify this minimum database capacity and the maximum database capacity. And what we do is we are going to scale this database instance between this minimum and maximum. So how do you think about what to set for your minimum, what to set for your maximum? The minimum is going to be what your database is starting at, independent of what the workload is. If you create a new database, that is the number your database is going to start at. If your database scales up and then workload goes away, there's nothing, it's going to start scaling back. Again, the minimum is the number that it's going to come back down to. Even if your workload is lower than what you assigned your minimum to be. Let's say I said my minimum is 4 ACU, but my workload only required 2 ACUs. I'm still going to stay at the 4 ACU level. We're not going to take you lower than the minimum that you specified. The other thing to note is, I just mentioned that the scaling rate, that is dependent on the current database size. So if you see that there's a spike coming up, what you can do is you can increase your minimum so the scaling rate that you get is corresponding to what you require, what your workload requires. Let's take an example. Let's say you have a blog post and you know that on weekends, it sees more traffic. So right before the weekend, you can go in and increase your minimum. So right when your database is starting off, it gets a higher scaling rate that you require for that upcoming spike that you have. Now the maximum one. Maximum is essentially your budget control measure. You're saying that I am willing to pay this much money. In a way, we will increase the database capacity beyond that maximum that you set. So a couple of things to keep in mind also is look at the peak workload. What does your peak workload require? So when you're thinking about the maximum, just make sure your peak workload is covered. Other things are if you're running any other features. So if you're running performance insights, for example, that may require more resources. And if your maximum is such that we're not able to give enough resources to these additional features, you're going to see some degradation. So what you want to do is look at what features you're using and assign the minimum and the maximum based on that. So now, with today's announcement, I'm happy to say that we are supporting both Aurora MySQL and Aurora Postgres. With MySQL, we're supporting 8.0, and with Aurora Postgres, we're supporting 13 version. So I've said a lot of words. Now is the exciting part. So Chirag right here is going to show you in action how all of this works.
Thanks, Anam. That was awesome. So yeah, like as Anam said, in the second half of the session, I want to demo some of the key features of Aurora Serverless, that is scaling, how does it work with global database, and more importantly, how do you get started, right? So speaking of started, let me show you the very first demo where I will be showing you the console, and there are some few new additions you will find in RDS console, and we'll go ahead and create our first RDS Aurora Serverless V2 instance. All right, let's get started. So this is your familiar RDS console. Again, Aurora Serverless is a feature of Aurora, so you still be going to the same console. And to create a cluster, okay. Sorry about that. Technical difficulties. All right. Okay, so here we're going to click on the orange button to create a database. And again, you'll be going to the same RDS console where you have different engine options. Obviously, you're going to select Aurora, Amazon Aurora. And it comes again, as we mentioned, both in MySQL and Postgres compatible. One of the options that you see here is the hide filter, where you will see the option for show me the version that supports serverless v2. Like Anum said, it's going to be either Postgres 13 or MySQL 8.0. In this case, I'm going to use Postgres 13. I'm going to give a first friendly name to our cluster called Demo Serverless, and I'll leave the rest default here. And here's the new part that you'll see in your console is the instance configuration. So instead of providing the instance, you'll be choosing serverless as your instance type. And this is the place where you'll be setting your min and max ACU. So in this case, I'm going to set up 0.5 and 64. And that's about it. And then I'll be creating a database here. And now, if you look at it on the bottom of the screen here, the size, it shows that you have a serverless instance. You don't see your regular instance type here. And also you see the min and max ACU. Now, think about a situation where you set some min and max ACU, but you might want to change your min from half ACU to maybe 4 ACU. You can certainly do that. So to do that, again, what we'll be doing is you can modify the cluster and set that value. So let me go and do that next. So you're going to click on Aurora Serverless cluster, and you'll be changing your capacity to whatever capacity that you need, min and max. And I'm going to leave everything default. It shows you the summary of what change you made. And at this point, instantly you will have a new scaling factor from 4 to 64, right? So once you set your capacity, it is always possible to change your min and max, right? All right. Next thing, what we want to do is something here. So the next thing we want to talk about is some of the changes that we have done in the CLI, right? So if you're familiar with creating cluster with AWS CLI, there are a few things to notice here. So when you create an Aurora cluster, there's two parts, especially through CLI. First, you create a cluster, and then you create an instance. So when you create a cluster, you will see a new option. On the left side, you see the provision Aurora command. On the right side, you see if you're creating serverless cluster. The only change you have to make in this case is the option for serverless v2 scaling configuration. So this is the place where you will set your min and max ACU if you are deploying your database through CLI. And when you create an instance, again, a small minor change, instead of putting the instance type, you'll be, in this particular example, you have an instance type of a DBR6 large. But then if you're using a serverless instance, the only change that you have to make is the new serverless instance type called db.serverless. So that will enable your serverless instance. All right, now let's talk the scaling. Anum talked a great deal about the scaling, how we do a fine-grained scaling and instance scaling. So in this part of the demo, I've developed a small app which is a flash, it's an order app where you're ordering something and there is a sale that happens. So this is a great use case for serverless database, right? So when the demand comes in, you want to scale your app and the database. So in my setup, what I have is I have a Python script which is pushing in orders to my Lambda app. And Lambda being serverless, it will grow and shrink based on the demand. More importantly, what I have in this demo is it's backed by a serverless v2 Postgres instance. So as you can imagine, what will happen here is that as the load increases, as I'm ordering more during the flash sale, my Lambda will scale up and down based on the requirement, and also the database will scale up and down. So when I start my load, what you will see here is that first I'm going to start the load through my Python load generator, and you will see a CloudWatch metrics, which is showing you the number of orders, and the other metrics is going to be Aurora Serverless capacity. So we're going to see that how, as the order comes in, how does the capacity or the serverless capacity is growing, and more importantly, we'll highlight how it's shrinking. All right. Okay, so we get started here. Okay, so first I have a Jupyter notebook, which is going to fire some workload. Again, it's a Python tool, which I'm going to run, and it's going to run my load here. And now I'll switch the screen over to the CloudWatch metrics. Now here you have a you have a green one, which is showing you the orders, and you have a orange one, which is showing you the serverless capacity. And you can see now that as the orders are coming in, your serverless capacity is scaling in tandem with how the orders are coming in, right? So it started, my server was like half ACU to start with. But now, if you look at it on the left side, on the y-axis, I have the order count, which is almost like at 3,000. And I've jumped up from 0.5 ACU to 10 ACU. Now, this is a short sale where the green one is coming down, where the flash sale is ended now. The order has come down, but my capacity is not coming down instantly. So this is one of the key features of serverless, that we will not take away the capacity instantly, but we'll take our time before we scale down. So you see that now the scaling down is happening much more gradually. If the demand comes back in, we should be able to give it back to you, right? So again, as Anu mentioned about the whole buffer cache, and we don't want to evict something prematurely, we scale in a much more graceful way. All right, now I want to talk about high availability and read scaling. So when you have a demanding workload, not only you need high availability, but also you probably need some more read scaling, and Aurora supports that. So in Aurora today, even in provision, we support up to 15 reader node, and that can act as your failover target. So in any event, any hardware failure or any AZ outage, Aurora will automatically fail over your writer node to one of the available reader node. As I said, you can have up to 15 reader node. Now, which node it will fail over, it depends on the failover tier, or we call it priority target. So when you create a reader instance, you can assign between 0 and 15 as a failover target. 0 meaning it's the highest priority, and 15 being the lowest priority. That's how it works in Aurora. But with serverless, there's a different definition here. With the serverless, what we do is we have two tiers, special tiers, the 0 and 1. They're acting as your highly available node. So when you fail over, you want to fail over to those nodes. And the way it will work is when you have any reader node with a failover target of 0 or 1, the ACU of your reader node will scale in tandem with your writer. So let's say your writer or your primary instance is at 26 ACU. Even if nothing is happening on your reader node of the tier 0, it will scale in parallel with the writer. And the reason why we do that is for the high availability. In case if you want to need to fail over, when you fail over, you'll have that capacity that you need. And more importantly, anytime you create a cluster like I showed in the last demo, the min and max ACU is at cluster level. So any reader node you create, they will inherit that same value. But based on the tier, it'll work differently. It will work differently for tier 0 and 1. If you have any tier higher than 2, then they will scale independently of the writer, right? And just like we do today with Aurora Cluster, if you need 99.99 cluster uptime SLA, with the serverless, you can have that with 2 nodes in a 2 different AZ, and with one of the node being either nodes or tier 0 or tier 1 replicas. All right, so here I have this quick animation to show you how that works, right? So what you see here is that cluster, you have the Aurora storage on the bottom of the screen, and you see 2 cluster endpoints. One is a custom endpoint, and one is a cluster endpoint. So let's first talk about what is cluster endpoint. So cluster endpoint in Aurora is an endpoint which your application will talk to, and it will always point to a writer instance. We do have a reader endpoint, and the way reader endpoint works is if you connect to the reader endpoint, your application will get routed to one of the available reader in a round-robin fashion. I'm just showing you here the writer only. And on the right side, you see a custom endpoint. So custom endpoint, as the name suggests, you can create an additional endpoint, up to 5 custom endpoint, and you can group certain reader node to become a part of a cluster endpoint. And why do you care? It is handy when you want to run some reporting app, which you want to target to a certain instances. So in this case, what I'm doing here is that I have a cluster endpoint, which is my application is pointing to, which is connecting to my tier 0 writer. And I have a tier 1 reader. And then I got 2 more readers on tier 14 and 15. So my custom endpoint is under the 2 readers which are on the higher tiers, which are 14 and 15. So what will happen is, as the writer gets the workload, the tier 0 writer is going to scale, as we've been talking about, that as this load comes in, it'll scale in and out. But also the tier 1 reader, which is your failover target, will also scale in tandem with your writer, right? As long as you have a reader with the tier 0 or 1. How is it going to work with the higher tier? Anything higher than 2. In this case, I have 2, which is 14 and 15. The way it'll work is, so let's say you have a reporting app, which is talking to a custom endpoint, which is talking to in round robin both to 14 and 15. Now they will scale independently of what's happening on the writer, right? So think of a use case where you have a reporting app or you need something which is very demanding, but it only happens certain times of the day, and you only need for only fraction of the day. In this case, this becomes a perfect use case where you can have a serverless reader on a higher priority. So we'll give you the capacity that you need for reporting app. And once it's done, it'll scale down. All right. To show that, I'm going to show you the demo. I'm going to use the same setup that I had earlier. So I have the Flash demo as my database. I have 2 serverless instances in it, and both are of the priority tier 1, right? So they are like, they have the failover target of 1. What I'm going to do is I'm going to add a 3rd reader of a failover priority tier of 15, and then I'm going to push some workload against it, and we'll see how all my 3 node behaves. So you would expect your first node, the writer node, and the first reader node, the Flash 2, will kind of scale in tandem with the writer, while the 3rd one is going to do its own thing. All right, so let's see that. So first thing, I'm going to go ahead and create a replica, which is fairly easy. You can just add a reader. I'm going to call it Flash 03 as my 3rd reader. This is a existing cluster, so you don't have to define any ACUs. It's already part of the cluster. I'll leave most of the stuff default here, except I'm going to set this up as a tier 15, right? So this is the reader node, which I don't want to scale as the writer is scaling. And I'll leave everything default here, and I'm going to go ahead and add a reader here. All right, so now you can see that we have the 3rd node added. So Flash 1 is a writer, Flash 01, Flash 01 is a writer, 02 is the tier 1 reader, and now we have Flash 03. I'm going to push some workload against it, and we'll see the CloudWatch metrics of how the ACU is going. All right, so here you see that in blue is your writer. The orange one is your Flash 02 is your tier 0 or tier 1 reader, and as you can see that it's kind of scaling in tandem with the writer. Nothing is happening on that node, but it's still scaling. More importantly, if you look at the one on the bottom, the green one, which is the failover priority of 15, it's doing its own thing. So I'm running in the background a tiny workload against that custom endpoint, which is pointing to the Flash 03. It's scaling its own way, and once the task is done, it'll come down. Same thing with the scale down. As my writer is scaling down, the blue bar, the chart line, you see that it's coming down, and the orange is kind of following that, right? One thing to point out here is that if let's say if your reader, Flash 02, which is the reader node, has more demand than the writer, we will give you that ACU. So it's not that it's always going to follow the writer. If the writer needs 10 ACU, reader 1, or in this case, Flash 02, will go to that ACU. But if it needs more than that, we'll give it to you, right? So it's more of a high availability play, and we'll get you that ACU when you do failover. All right. Now let's talk about Aurora Global Database. So Amazon Aurora Global Database is a feature of Amazon Aurora, and it's available for both MySQL and Postgres compatible. And it's really designed for highly distributed application. and you can span your single database across multiple regions. So think of a use case where you have a globally distributed application, and it requires a global presence. And more importantly, you have a very strict SLA around regional outages. And the second example could be you have this globally distributed application might need a reader closer to your end user in various regions. So this is where our global database comes in picture. So the way it works is you can have a primary region. Let's say in this case, it's in US East. And you can create very simply a secondary region across the continent. In this case, it's on the west coast of the US. And any event of a primary region were to go out, you can quickly promote your secondary region to become a writer instance. And you can do this in less than a minute of a downtime. So you can fail over from your primary region over to the secondary region. More importantly, global database supports up to 5 regions, and each region can have up to 16 nodes. So you have a pretty good read scalability, and with the 5 region, you can have up to 90 read replicas. Now, another important thing to notice here that the way the replication works in Aurora Global Database. So as you do the replication in Aurora, it's all physical level replication. So that's exactly why we can provide you a lower latency reader nodes across the region, is because of the physical replication. And we use a dedicated hardware to do this replication. So we don't have to touch your existing database instance, and they can do their work on the database side. All right, how it'll work with serverless. So this gets a little more interesting now. Now what you can do is, you would like to set up a regional disaster, for regional disaster recovery, you want to set up a secondary instance. But you want to pay for a minimal capacity when you're not using it. And this is where the serverless V2 makes a lot of sense here. You can now, with serverless V2, create a secondary region, and the instances of those secondary region can be serverless. So you can have a provisioned writer on your primary region, but just to keep as a pilot lamp in the secondary region, you can create a secondary region with a serverless reader. And just like we said earlier, if you set it up with a failover priority 0 and 1, it'll follow the writer ACU. If you don't, you keep it at a higher tier, and they will not follow the writers. So in this case, in case the primary were to go down, I'm making an assumption is that primary is on provisioned, and you have a failover target, which is running serverless, which you're not going to fail over to unless required. And with this, you can fail over to that secondary region. And when you fail over, remember, these are serverless. So as soon as it gets the load, it'll start to scale up, and they will become the writer at that point, right? And then if you wish, you can switch them back to provision, however you want to see it. But again, the important thing here is that it's now very easy and cost-effective to set up a secondary region and have a Aurora Serverless V2 running there with a minimal ACU, half ACU to start with. So it's available for you when you want to fail over to. All right, so a quick demo. Just want to show you how do you add a region to existing cluster, right? So here you have a orders database, and it's running on AP South 1C and 1B, and I want to add a region here for my failover, and I'm going to choose the serverless as my instance type. So here we go. All right, so first thing first, I am going to add a region here. So to adding a region here, you're going to do an action bar, and you're going to click on Add AWS Region. You're going to give the name of the cluster. And for this one, I'm going to choose US East as my region. And again, this is the first time I'm creating a serverless instance in this cluster, so I'll have to do my instance type and min-max ACU. And I'm going to leave everything as default, and going to add a region. And now when I add a region here, it's going to go and create a cluster in that region, and it's going to create an instance in that region. So now you can see that I have a global cluster 1 in US East 2 coming up. And the instance type that you see here is that it's of serverless v2 now. So now we have, think of it as a pilot lamp running in the secondary region with a minimum ACU, right? So you're doing all your work in a primary region, but you have something to fall back to if needed, and it'll scale when you do. So now you can see that it's doing its thing of backing up the cluster and creating instance. And after a couple of clicks here, we should have an instance up and running in US East 2. So just a couple of seconds, it does the monitoring of it as well. And at this point, we have the entire global cluster created. And you can add up to 5 secondary regions, just like that. All right, moving on. Anu, I want to pass on to you for the next performance metrics.
So now, let's say you're running into issues. You want to troubleshoot. What do? So with Serverless v2, we are supporting RDS Performance Insight, which is a simple and powerful dashboard which helps you visualize your database workload. So here, if you see, we have average sessions, and on the y-axis, that's the timeline. So the important thing to note here is the dotted gray line. That is what specifies your estimated vCPU. Now, here you can look at the chart and see that maybe your workload requires more optimization. You need to optimize more your queries, for example. Or you can look at it and maybe your conclusion could be that, no, maybe you need to give your database more resources because your workload is already optimized. So you can increase your maximum database capacity. So you can use RDS Performance Insight along with Serverless v2. Talking about monitoring, you saw Chirag's demo. He was showing you CloudWatch. Within CloudWatch, he was using some metrics to help you understand what exactly is happening inside the database. This is not a black box. We want to show you what is happening, and then you can also see why certain things are happening. So one of the metrics that Chirag was using was the serverless database capacity. This is your current database capacity. So at cluster creation time, you specify just the min and the max, and when we're scaling, that is your current database capacity. So you can look at that database capacity by looking at this CloudWatch metric in ACUs. So the other one, I'm only going to talk about a couple of CloudWatch metrics, the ones that pertain to serverless. And there are a lot more other metrics that you can use. Look at the documentation for those. So the second one I want to talk about is ACU utilization. It is a percentage of the current capacity out of the maximum capacity that you specified. So the way you look at it, if you see that the chart is getting close to 90%, 100%, that means you need to give your database more resources. And same goes for CPU utilization. This is also in percentage, so the percentage of CPU based on the maximum ACU that you're currently using. If you're getting close to 80, 90%, give it, increase the maximum database capacity so you'll get more CPU resources. And the last one I want to mention is freeable memory. So this is the memory that is available for your workload. And if you see that not a whole lot of memory is available, again, you go in, increase your maximum database capacity to give more memory for your workload. The next feature I want to talk about is RDS proxy. So with this launch today, Aurora Serverless v2 will support RDS proxy. So now think of scenarios where you have application running, which are opening lots and lots of connections. They're keeping them open. And how does your database manage with it? So you want to make sure that you're not using up your precious database resources managing those connections. You want to preserve those resources for your actual workload, your transactions. So what you can do is use this fully managed, highly available database proxy. You can put it on top of Aurora Serverless v2, and it takes the brunt of opening those connections and managing them for you. And you end up saving your resources for the work it's actually expected to do. You're running your transactions. With RDS proxy, you also get high availability. So Aurora gives you automatic failovers, and you can get faster. The failover time, you can reduce it by 66% by using RDS proxy. You also get better security. So with that, I want to talk about how can you get started. So Chirag, tell us what's the process.
All right. So by now you must be thinking, okay, I'm running my Aurora provision right now. This all sounds really good. I have a use case where I can use serverless v2. And we're going to see here how you can quickly adopt serverless v2. So what we call here is that we have Aurora cluster in a mixed configuration. So as you can see in the diagram here, what we will support here is that we can attach a serverless instance on your existing RDS or a database. So if you have a provision writer and a provision reader, you can add a serverless reader on the same cluster. And if you're ready to switch over, all you need to do is a failover to that serverless reader. Upon failover, it will turn into a writer instance. And since we talked about earlier about the cluster endpoint, which always points to the writer instance, that cluster endpoint will now point to the newly promoted serverless writer. And this is how easy it is to switch from a provision cluster to a serverless instance. And once it's connected, now it'll scale up and down based on the demand. And if you like, you can keep the provision or you can recycle all the provision, just like the same method. You can keep adding more readers and then recycle the old provision writers. All right, so now let me just quickly show you. This is a typical setup you might have. You have a provision instances, you have a writer and a reader. I'm going to add another serverless instance on it and then do the failover. So here we go. Okay, so in order to do that, we will again, like we've done in the past, I'm going to add a serverless instance. This is, remember, this is your provision instance here. And I'm going to call a name here called Demo Serverless 01. And since this is the first instance of a serverless type, again, you're going to be doing your familiar by now, the min and max ACU. And you'll select the serverless v2 as your instance type, obviously. And we're going to select a different AZ. And the rest can be default. And I'm going to add a reader. So again, what we're doing here is that on an existing provision cluster, we added a serverless instance of the capacity that you need. And we're going to wait for that instance to come up. Now that we have it, now what we can do is you could do some testing on, this is a reader instance, by the way, right? So you could do your testing on the reader instance. But when you're ready, just like you did today, you can go ahead and do a failover onto that node. And to do that, just click on action and just failover. It's a fairly quick process where it's going to kick off the automatic failover process. And what you can see here right now that DBR5 is still a writer instance. And the status is now showing failing over. And once the failover is done, your writer instance is now serverless v2. So that's how easy it is to move from, or if you intend to move your provision to serverless instances. There are other ways, maybe if you want to do choices to do the conversion. So there are a few other options. You can do cloning, you can do a snapshot restore, or even you can use native replication if you want to adopt serverless v2. With that, we're going to conclude our talk, and really thank you for coming out, and I hope you enjoyed the session.
Thank you so much, everyone.
Thank you.
We'll hang around for a couple minutes, so if you have any questions, please do come up.